Okay, ladies and gentlemen, let's start going over these. Got something very simple, I'm hoping. This is just pulling everything together. So, take a look at your answers. Number 1 was -2, 2, -17, 3, 4, 4, 12 over 7, 5, -5 over 6, and 6, -1 over 6. I think I'm right. For which one? Because if I have 0 over 0, I know it sounds weird, but you can't even divide 0 by 0. Okay? You'll have some fun little rules in calculus if you go on with that. L'Hopital will become your friend. It's called indeterminate form. All right. Any questions on these problems? Are we good? Yes? Yes, sir. Because you can, but it's not going to, guys, please. I didn't factor out a 2x squared because I knew it wasn't going to cancel with the top. So I just pulled out what I knew it was going to cancel. You get the same answer either way. Yep, because you would have had 2 times 2x minus 3. And then when you plug the value in, you get the same thing at the end. Okay? All right, so, 1 second. Augsburger. Hey. Okay, yeah, sorry, it was Latora. My brain is not making connections, so that's why I thought it was weird. I was like, Latora was calling for Hintosh? Yeah, thank you. Bye. I really don't know who she said. My brain's not functioning. Okay, anyways, here we go. Moving on. So, we've already talked about this. We're just now formally going over it. And it is just the definition of continuous. What does it mean for a function to be continuous? Well, it means exactly what I said previously. Something is continuous if the limit as we approach a point is the same thing as the function at that point. So it's easy to do looking at a picture, because you can also say, I don't know, does that look like continuous? Yes or no? So if I look at 2 here as x goes to 2, would you claim your function is continuous here? No. What kind of discontinuity do you have? This is a removable. Removable because if I were to simply paste over that little point there, if I were to move this here, that would remove the discontinuity. So, if I were to talk, however, about limits, what is the limit as x approaches 2? Careful. Pay attention to what we're counting by. The limit as x approaches 2. 1.5 or 1.5? But what is f at 2? 3. So, is f continuous at x equals 2? No. And if I ever ask you the question, is f continuous someplace, and I didn't lead up with this stuff, you would need to say yes or no, because the limit as x goes to 2 for f of x is 1.5, which is not the same thing as f of 2, which is 3. Okay? That not equal to thing right there, that screams discontinuous. Okay? Now if we look at 1, if I look at the picture, would you say that f is continuous at 1? No. What kind of discontinuity do you have? We have a jump discontinuity. So overall, if I'm looking at as x approaches 1, what is the limit there? Very good. Why does it not exist? Because it does. Okay, I need a little bit more than that. Yeah, it's a jump discontinuity. You can say from the left, it's approaching what? Negative 1.5. From the right, it's approaching 0.5. So since those two are different, it's discontinuous. And then f at 1, what is that going to be? Negative 1.5. So you can see here there are two different ways that your function can be discontinuous. You can have a removable. You can have a jump. We also have one more, discontinuity, which is that? Infinite. All right, so x is not continuous at 1 because that does not equal that. And even if they were both does not exist, that still would not work. So I want you guys to try 7 through 12 for me. Go ahead and answer those guys. All right, did you guys get that? Yeah? Okay, let's take a look at your answers, see if we agree. I got a no and a yes. So what I'm looking at here that I want you guys to see, if you get a limit does not exist, then you're going to have it is not continuous. If you have an infinity, it's not going to be continuous there. If you have numbers that are not equal, so these two are not equal, it's not going to be continuous. So we've done all of these things before, right? Not a scary moment. So the only thing that I want to kind of focus on now, the thing that we haven't quite talked about, is how to do piecewise when we're not looking at a graph. And it's really not that bad. How was I able to determine if a piecewise function was continuous? By plugging it in. Guess what we're going to be doing here? Same thing. So let's go ahead and let's just plug this in here, and let's plug it in here and see what we get. So when I plug it into the first equation, what do you get? 2. What about the second equation? So what would you have said? This is discontinuity, and what kind is it? This is a jump. So we would say, no, this is not continuous. And that came straight from the old way to do it. But to justify it in the current way that we're doing it, we need to be able to understand what this here says. What does that plus sign mean? It's coming from the right. So are those numbers, is that where I'm talking about x is greater than or x is less than? We're looking at where x is greater than. That's coming from the right. So is that the first equation or the second? The first. So that means when I substitute 1 into the first equation, I get 2. What this is you have to figure out which equation we're coming at. So when I see a negative 1, that means I'm coming from what side? The left. And so that's where x is less than 1. So what you can think about here is if that's your x, this is the stuff that is greater than x. This is the stuff that is less than x. So this is the limit from the positive side. That's the limit from the negative side. And so when I come at it from the left, what's my value? -3. Good. So overall, what is the limit? Overall, it doesn't exist because those two are not the exact same thing. And when I say f of 1, which equation am I talking about? Why the first one? Because that's the one that's equal to. So this guy is going to be 2. And so when we're saying f is not continuous, that is because we have a discontinuity. It's also because those two numbers are not the same. So there's all sorts of these different places that you can look at for it. I want you guys to try 18 through 22. 18 through 22 for me. Compare your answers with your neighbor. You're just asking you to do 18 to 22. Wow, you guys are doing absolutely no comparing your answers with your neighbor. Come on. I know you're excited and you just want to finish this, but... Got it? So all of those problems are dealing with the function as I approach or am at what value? -2. So which equations am I looking at? The first one, definitely. Any others? I'm looking at the first one and the second one. Do you guys get what I'm talking about here? Because I could graph this as a piecewise function, and I would say, okay, where x is less than -2, I would be like down here. Then I would be like right here. And then I would have something else. But do you understand what I'm talking about when I'm saying all of these involve the number -2 for x? So -2 for x happens here because that's x is less than -2. This is actually saying x is what? -2, -1? Yes, sorry, thank you. Okay. Thank you very much. Good catch. Thank you, sir. All right, does that make sense? So for the next one, now I'm going to be switching gears, and these are all talking about 3. So the equations that involve 3 are here and here. So I'm going to need to go through and I'm going to need to plug different numbers into those equations. So when I plug 3 in, what do I get? 4. And when I plug 3 in, what do I get? So is that going to be continuous there? No. And let's get a little bit deeper as to why it's not going to be continuous. So again, I'm looking at those equations up there. Which equation am I looking at as x approaches 3 from the positive side? The last equation, because from the right-hand side, that's greater than. So I'm going to be looking at this one, and so what do I get? 5. Which equation am I looking at for 24? The second one, what do you get? 4. So the overall limit as we approach 3 does not exist. And it does not exist because these two are not the same number. But what is f of 3? 5. This time I have a value. I did not have a value. Why didn't I have a value for 21? Right, because if you look at it, neither one of those have the or equal to, so I don't have my function there. I just have a jump. Okay? And then again, it is not continuous, mainly because the limit does not exist. As soon as you get a does not exist, you're going to have discontinuous. Okay? All right, these are just different ways of looking at the same problem. If f is continuous at 0, can somebody tell me what's going to be true if f is continuous at 0? What's going to happen if f is continuous at 0? You're saying k is going to be 0? If f is going to be, the only thing that we should know for certain here, if f is continuous, then those two things need to be equal, right? But why am I saying x cannot equal 0 here? Because it's going to be undefined. But what can I do with that function? What have we been doing before? How would we find the limit of that? What did we just do with all of these problems if you saw something like this? Factor. Factor. That factors to be x times x minus 1 over 2x. What's going to happen? Your x's cancel out. So I get x minus 1 over 2. Now, can I put 0 into this? Okay, if 0 was here, what would you have? Negative 1/2. So that means the limit as x goes to 0 has to be the same thing as f of 0. So we've said the limit as f approaches 0 is negative 1/2. So f of 0, which was k, is also negative 1/2. Does that make sense what I just did there? You take the definition of continuous. The definition of continuous means the limit and the function are exactly the same thing. This guy, I don't know because it's got a k in it. I can calculate the limit as x goes to 0 because that just means that this guy also. Because this is this function everywhere but here. Okay? I want you guys to look at 29, see if that makes sense to you. See what you can do with that. Talk it out with each other if that helps. How do I know if something is continuous? The limit going to that value is the same thing as the function at that value. So I would look at this and I would start finding the limit and the function at 1, the limit and the function at 2, and then possibly the limit and the function at 0, because they're the numbers that they give me. Basically, we're going to finish up these last couple problems and then I'll give you another worksheet. That's it. Yay! No? All right, you guys think you got it? What's the answer?
B.
There you go. Own it. Say it with strength. The answer here was B. The answer is B, because as I go through and I do this, I first looked at the original equation, and I simplified it. I said, I know I'm going to have to do that anyway, so I'm going to go ahead and do that. And then, okay, just using the simplified function, the limit as x approaches 1 is going to be negative 3, which, hey, is the same thing as x at 1. So I know I'm continuous here. So that means I'm going to cross out those guys. And then I look at 2. The limit as x approaches 2, that's going to give me a 0 in the denominator, so that limit does not exist. That is where I am discontinuous. Okay? I'm going to do 30 with you. You're going to do 31 on your own, and we're going to call it a day. All right, so if I look at 30, In order for something to be continuous, what does that mean? The limit of the function as x goes to that value is what? The same thing as the function at that value. So let's see what we get when I do this stuff together. F at 1, because that's the easy one here. That is dealing with the first or the second equation. The second equation. So when I plug 1 in, what do I get? 1. And the limit has to mean that the other equation, as I start approaching 1, needs to be the same thing. So if I substitute 1 in here, what am I going to have? K plus 1. So what is K going to be? 0. Good job. That's it. So I want you guys to do 31 for me. Okay, check your answer with your neighbor when you think you got it. All right, so did you guys get it? What is P? You sure? Then say it like you mean it. -4. Basically, I put it in here. Because when x is -1, -1 squared is 1 plus 2. And then when I put -1 in here, I get -1 minus p. And those two are supposed to be equal. Yes, ma'am? -1 minus x. Oh, okay, so where you for some reason called that x when that's a p. So that's my big confusion. But yeah, that's generally the right idea. But you got to make sure that you understand that x is the variable, p is a constant, so you want to make sure that you're careful with that. Okay? All righty.